Welcome to Science Corner Tutorials. We'll be looking at science concepts in depth. Get ready. Let's get started. Okay, so we are moving on to the fourth lecture series on differentiation, where this time around we are differentiating using the quotient rule. So remember, we've done the previous three videos on differentiation where we laid foundation on different concepts that can be used when differentiating different functions depending on what is most applicable in terms of a particular function. So when do we use the quotient rule, when differentiating? So as I highlighted earlier on to say that you know it's very important that we get to understand that when dealing with functions and when dealing with mathematical problems, you've got to know when to apply a particular formula. It's not random. It's something that you've got to know very well when to apply it. You've got to know the formula first, and you've got to know when to apply it for you to be able to solve different mathematical problems. So when dealing with the quotient rule, when you've got a function, right, that is in the form y equal to u over v, like this one here, where u and v are the functions of x. You differentiate this by using the formula v, then you square the denominator. So v is your denominator, you square it here, so it's v squared. Then you keep the denominator constant, right? You take the denominator, you keep it constant, then you differentiate u, then you subtract, you keep u constant, which is your numerator, and you differentiate the denominator v. I think this is clear and straightforward. Make sure that you understand this. So let's jump straight into some some examples. So the first example that we have is differentiate the following function: y equal to x squared over 2x plus 1. So when differentiating this function, we say that on our formula, when differentiating using the product rule, any function of the form u over y. So this also x squared over 2x plus 1 is in the form of u over v, right? So what we say is that you keep your denominator v, right, as a constant, as a denominator, then you square it. So that's what we've done here. We have kept 2x plus 1 as a constant and we square it. Then we take our denominator, which is 2x plus 1, right, which is now here. Then we differentiate x squared. And if we differentiate x squared, you're going to get 2x, like here. Then we subtract, we now keep our numerator, which is x squared, which is the numerator here, right? Then we differentiate 2x plus 1, which is the denominator here. Then you're going to get 2. And you simplify this, you're going to get 4x squared. You multiply everything that is in the bracket. 2x plus 2x times 2x, you're going to get 4x squared plus 2x minus 2x squared. Then you subtract 4x squared minus 2x squared. You're going to get 2x squared plus 2x over 2x plus 1 squared as your final answer here. I'm hoping that this is making sense and it's straightforward and also clear. Make sure that you understand this particular concept. A second example, just to reinforce our understanding. So I've got a function here that is y equal to 1 plus 2x plus x squared over x cubed plus 1, which is this one. So this one, if you look, it's in the form u over v, where u and v are all functions of x, right? Then, how do we go about solving this? It's the same concept. You take your denominator here, which is x cubed plus 1, then you keep it as a constant and you square it, right? Then you come on the numerator part, you keep the denominator x cubed plus 1 as a constant, which is here. We've kept it as a new constant. Then we differentiate 1 plus 2x plus x squared. So if you differentiate this, you're going to get 2 plus 2x minus, you keep your numerator 1 plus 2x plus x squared as a constant. Then you differentiate x cubed plus 1. You're going to get 3x squared. Then from there, you simplify. So you multiply, you remove your brackets. So it's 2 multiplied by x cubed, you're going to get 2x cubed, plus 2 multiplied by 1, you're going to get 2. Then 2 multiplied by 2x cubed, you're going to get 2x the power of 4, plus 1 multiplied by 2x, you're going to get 2x, minus 3x squared multiplied by 1, you're going to get 3x squared, minus 2x multiplied by 3x squared, you're going to get 6x cubed, minus x squared multiplied by 3x squared, you're going to get 3x the power of 4 over your denominator. Then you simplify, and you're going to end up with this answer here. This is clear and this is straightforward. Make sure that you understand this simple concept. Then we can also apply the quotient rule when dealing with trigonometric functions. So remember, this trigonometric function is also in the form u over v, where u and v are functions of x. So it's the same concept that we applied when we were not dealing with trigonometric functions. So you're going to keep your constant here, cos x as a constant as a denominator, then you're going to square it right here. Then from there, you're going to keep it as a constant on the numerator part. Then you're going to differentiate the derivative of sine x is cos x, which is here in the brackets. Minus, you keep sine x in numerator here as a constant. Then the derivative of cos x is minus sine of x. So you simplify this, is cos squared x plus minus multiplied by minus, you're going to get a positive, plus sine squared x. Then you're going over cos squared of x. Then cos squared x plus sine squared x is equal to 1. So you're going to get 1 over cos squared of x. Then 1 over cos squared x is equivalent to sec squared x, which is your final answer here. So I'm going to do another video where I'll just tell you the equivalent of different trigonometric functions so that you can get to understand them better. Then another example that we've got y called cot x. So cot x is equivalent to cos x over sine x. So it's still in the form u over v, where u and v are functions of x. So from there, you're going to simplify the same principle that we applied. Sine x, you square it, you keep it as a constant sine, right? Then the derivative of cos is minus sine x minus cos of x, right? You keep this one as a constant. Then the derivative of sine x is cos of x. Then you simplify this, you're going to give you minus sine squared x minus cos squared x over sine squared x. Then you factor out the negative sign, you're going to get minus sine squared x plus cos squared x over sine squared x, right? Then sine squared x plus cos squared x is equal to 1, right? So you get, ultimately, you're going to get minus 1 over sine squared x, which is equivalent to minus cos sec squared of x as your final answer. I hope you understood this concept. Thank you so much.